Hello, everyone. Welcome to the review session of behavior economics. So in this session, I'm just going to help you to go through some key knowledge points of this course. And as I mentioned, it's going to mainly be focused on the first five topics of this course. Okay, so I'll just directly start with lecture one. So lecture one is basically the general introduction of this course. So we started with the definition, some definitions of basic concepts for behavior economics. So for example, we talked about what is behavior economics. So behavior economics is in general, right? The intersection between economics and psychology, and it tries to bring in the insights from psychology, bring in the psychological factors that helps to improve the explanatory power of economics. Okay. And we also mentioned briefly like the relationship and differences between behavior economics and experimental economics. So basically, the emphasis of behavior economics is the introduction of psychological factors, and the emphasis of experimental economics is the adoption of an experimental method. So behavior economics do not necessarily always do experiments, and experimental economics do not need to always have behavior factors or psychological factors. Okay, and then we spent pretty some time discussing a very interesting phenomena that is both in economics and psychology, the framing effect. So framing effect basically means that the framing of the problem also influences people's decision for a specific problem. So this is so basically just like the example we showed at the beginning, right? Like from the psychology, we have the Ebbinghaus illusion or Delboff illusion. Namely, the simplest example is like when something is surrounded by small articles, it will appear bigger. And if something is surrounded by bigger articles, it's going to be appear smaller in size. Okay, so uh, from traditional economics point of view, framing should have no impact on decision making at all. So basically, traditional economics is a kind of a frame free, right? Frame free. So you should only make decision based upon the profit or utility maximization principle, and your decision shouldn't be too much influenced by the framing. Uh, and we also do show like, right? So for example, like the example we um, show for subscription for the economies, right? The economies, we do see that basically when people have different reference options, they may end up choosing differently for the subscription. So um, this basically shows us that in real life, people's decision making is indeed frame dependent. So framing is very important. And also, we first time also introduced loss aversion, the concept of loss aversion in the context of a framing effect. So we say that um, loss aversion is a very important example of a framing effect, namely for the same thing, right? For the same thing, just like the disease problem proposed by Kahneman-Tversky, right? So for the same decision problem, people will also tend to make decision depending on whether the result of a treatment, medical treatment, is stated in terms of gains or in terms of losses. So that's the first time we introduce loss aversion. So it's an important here. It's a example of a framing effect. Okay, and then next to it, we introduced the concept of endowment effect. Endowment effect refers to the situation that people tends to evaluate the value or the price of an object differently, depending on whether they own it or they don't own it. And in general, endowment effect tend to suggest that people value something more if they own it compared to they don't own it. So it sounds a little bit like an ownership premium. So if you own something, you think that it's more valuable. And in terms of the specific, right, in terms of the specific uh, example or the way that that illustrate itself, we will say that endowment effect is expressed usually in terms of the gap between willingness to pay and the willingness to accept. So here, in order to understand endowment effect well, you have to, right, kind of also understand the willingness to pay and willingness to accept very well. So willingness to pay is basically the maximum price you're willing to pay for something. Willingness to accept is kind of the lowest minimum price you're willing to sell something. And normally willingness to accept is bigger than willingness to pay. So for the same product, you think that it is more valuable when you own it and it's going to sell it, and you tend to think it's less valuable if you don't own it and you're supposed to buy it. So that's called endowment effect. Okay, so that's the concept for endowment effect. And then we also think about the power of default. So power of a default is like default choice that also does influence people's behavior. So for example, right? So I think the most important example we used was this blood donation in Germany and Austria. So basically, in traditional economic theory, right? So if you give people a default choice, but you allow them to change it freely, so then in general, um, the people's choice under different default settings should be the same. Just like if you're supposed to choose between A and B, right? Um, no matter I tell you the default choice is A or B, in the end, your choice doesn't depend on the default because you're free to choose it. So traditional economics basically predicts that you're just going to choose A if you prefer A. You're just going to choose B if you prefer B. And doesn't depend on which one is the starting point or the default choice. But behavior economics research in general tells us that default choice actually matters a lot, a great deal for the outcome. So in general, people are much less to change the default choice. People are much less to change their decision from the default choice. So basically, if you make one of the options the default option, people are much more likely to stay with it instead of moving to the other. So default choice is indeed a very important factor in decision making. Okay. And so also that is why like when we discuss the exercise, right? The exercises, we also say that suppose if you want to promote a choice, what can you do, right? So the easiest way is like in the opt-out system, you make it the default choice, right? So opt-out, so basically this part, we also introduced the terminology called opt-in system and opt-out system. Opt-in means that by default you are not in. You need to indicate you want to be in, then you can be in. Opt-out system means by default you are out, and opt-out system it means by default you are in, but you can only move out if you indicate that you want to leave the default. So therefore, if you want people to choose A, right? So in general, you should make it a default choice under opt-out system such that most people will just not change it, right? So yeah, so basically, and also we say a little bit about intuition here, very simple intuition. In general, people are kind of lazy, right? Default choice partly because people are lazy. People are lazy to change, make any changes. So that is why if you make something the default option and they need to take effort to change it, so they don't feel like changing it. So that's why you have default choice. Uh, the effect of the default choice. Okay. And lastly, we also talk about power of a comparison. So power of a comparison is more like if you want to encourage some behavior, you can try to, right? We can try to make competition. You can try to make a competition. I think as we see in the example of electricity bill or energy bill, right? So, um, so you can encourage more environmental friendly behavior by showing people that their neighbors are doing good. So they should try to compete with their neighbors, give them this kind of feeling that they want to compete with their neighbors in doing good things, and that can help you to achieve socially desirable goal. Okay, so that's basically the several key knowledge points of lecture one. Of course, besides that, right, we also talk about examples of nudge, like if you want to encourage people to do some behavior, just telling them what to do may not be very effective, and you might be it might be easier for you to achieve this goal if you um think about, let's say, first, like making the desirable option more fun for people to choose it, right? And also something interesting is like if you talk to them in terms of more imperative wording or in polite wording. Surprisingly, actually, imperative wording is more effective in persuading people to do something. Okay, and yeah, so that's basically we have some examples of nudge uh, here, and we also mentioned some similar examples in later chapters. And also, yes, at the end of lecture one, actually, I also briefly talked about social preference to you. So, social preference is another important topic for behavior economics, even though we didn't have much time to cover it. So basically, traditional economics assume that people only care about the material or monetary payoff for themselves. And but through experimental studies like Ultimatum Game or Dictator Game, we do find, right? We do find that people tend to actually care about others' well-beings. They may be altruistic about others. They even if they have the power to take everything from their opponents or but normally they don't do that. They tend to, let's say, if they have $100, even if they can take all the $100, they tend to leave like 20 to 30% to the other player. So that's uh more or less like about lecture one. Then we can think about talk about lecture two. Lecture two is a kind of a bigger topic. Basically, lecture two is a big topic about people's decision and a risk and uncertainty. So we go through the important theories one by one. Okay, one by one. So the first one is the expected value theory, right? Expected value theory is just like if you want to make decision under risk, you just calculate the expected value of monetary payoff, all right? So and you choose the larger one. So that's the simplest one. and that's the one you have already learned a lot from your middle school or junior college. And then the first thing is we introduced, right? We started with this very famous paradox. I hope you can still remember the name of the paradox is the St. Petersburg paradox. So St. Petersburg paradox basically said that if you have a kind of a jar, right? You flip a coin, the money in the jar will double if there's I think it's a tail or a head. Uh, well, either way, right? So let's say it will end with a head or will double with a tail. What is the expected value of this sorry. So the game, the lottery to win all the money left in the jar. So if you use expected value, you will find that the expected value of the lottery is infinity. But in real life, people are rarely willing to pay more than right $10 for the lottery. And basically, that says that expected value is not the best model to predict people's behavior uh, here. And we introduced the expected utility. So the big idea of expected utility is that people may have nonlinear, right? Nonlinear utility of money. So traditional economics think that people have just like linear utility or one-to-one utility on money. But actually, we do see that from expected utility theory, you may have linear or convex or concave utility of money. And in particular, uh, the concave utility of money, namely the diminishing marginal utility of money, will imply risk aversion, and that can help saying that okay, especially for this things like a St. Petersburg paradox, people would prefer much more assured payment compared to uh, risky payment. So that's the expected utility theory. Okay. And we also talk about several axioms of expected utility theory. And I think among them, the most important is probably the independence, right? These things. And yeah, so basically, um, we say that like the expected utility model depends on several axioms, but right later on we also soon observe that people may easily violate the axioms of expected utility theory, such as the Allais paradox, right? Such as the Allais paradox. So basically, it means that if you do a linear combination of the risky lotteries, um, people may behave differently compared to what the axioms would suggest them. And in particular, right? And in particular, it's more like if you let's say if you people will choose okay, so people will appear to be risk averse in normal situations, but they may appear to be more risk seeking when the winning probability is very small, right? When the winning probability is very small. And also, based on that, right, we also proceed to the fourth knowledge point, key knowledge point, which basically say that if you look very carefully, people are right. People are they are they are responsive to different degrees to the probability change. So basically, that's the actually the most important insight brought by prospect theory, which means that traditional economics or expected utility theory tend to think that they tend to think people will treat 1% as 1%, right? They have kind of a linear perception or linear weighting of probabilities. But uh, but we do see that in real life, right? People people's responsiveness to probability change is different depending on the domain or region of the probability. So in general, people are more sensitive, right? People are more sensitive to probability change between, uh, let's say 95% and 100%, between very sure to surely sure, right? To 100% sure. And they're also very sensitive to probability change to from zero probability to 1%, 2%, 3%. At the same time, people tend to be not so sensitive to probability change in a kind of a median level of a probability. So, like if you change from 60% to 65%, basically most people will feel like there's not too much change. And people will feel there's a lot of change if that's from 95% to 100%. So just like several examples in our slideshows, right? So that's the most important insight of prospect theory. Namely, people have nonlinear weighting of a probability, and in general, they tend to give a higher weight to probabilities near 0%, 100%, and tend to give lower weight to probability change in the kind of a middle level of probabilities. Okay. And then we briefly mentioned something about ambiguity. So ambiguity, right? So first thing is that I hope all of you still remember, right? Ambiguity. So broadly speaking, we say risk and ambiguity are both uncertainty. Okay. So risk refer to the situation that it's uncertain, but you know the probability. And ambiguity, like in this cause per se, which is just said, ambiguity is like it's really uncertain. You know it's uncertainty, but actually it's really uncertain. You even don't know the probability of each state to realize. Okay, so just like the kind of the jar problem we thought about, right? So let's say risk refer to the case that there are 100 red balls and blue balls, right? You know the composition, you know it's a 50% or 60% or 20% red balls. And ambiguity is just like I tell you, there's a jar, there are blue balls and red balls, and I even don't know what is the fraction of both, what is the probability of both. So yeah, so that's basically ambiguity. It's like a even uncertainty about the probability. And in general, the insight from studies in this literature is that people seem to appear to have ambiguity aversion, which means that even though on expectation, the two situations may have similar probability, but people would prefer risky options over ambiguous options. Okay, that's more or less the idea. And then we also discuss the loss aversion and endowment effect. So here we try to say that maybe loss aversion is more fundamental than endowment effect. So under prospect theory or loss aversion model, we can always say that um, why people have a gap between willingness to pay and willingness to accept. That is because willingness to pay is like you're losing money and getting the product. So you're going to value money more and value the product less. So naturally, you are going to offer a low price in terms of money for the product. And by the same argument, right, your willingness to accept is like you are giving away the product and getting the money. And in this case, you're losing the product. So you're going to value the product more and value money less. And therefore, you're going to charge a higher price because you are going to get money. Okay. So that's the general idea. And I even say that I presented to you the loss aversion model and suppose that the loss aversion model tells you, right? So for $1 loss, your pain is lambda, right? Lambda is larger than one in loss aversion model. Suppose that you know for $1 loss, the pain, right, is a lambda dollar in terms of gains. And then we even have this kind of calculation, right? So basically, if we have this relationship and we have suppose linear utility in other ways, in general, you are going to expect something like the relationship of lambda squared before willingness to accept and willingness to pay, right? That's a that's another result of this part. Okay. And yeah, so at the end of this lecture, I also introduced some behavioral finance examples like disposition, effect, and so on. Um, I think in general, it's also yeah, disposition means that you are too quick realizing. I think realizing gains, and you're too people are too slow realizing losses. Okay. And basically those are also some interesting phenomena. I hope you can know and could be able to understand it from behavioral economics point of view. Then we have lecture three. Lecture three, we have discussion about heuristics and biases. Okay, so we mainly talk about three biases in this lecture. So called the representative bias, availability bias, and anchoring bias. So representative bias, I think we spend most of the time on representative bias. It's just like if you remember, right? So basically, people or sometimes we also call it base rate neglect or base rate ignorance. So it's just like when, let's say, if you are on, let's say, MRT, right? You see a lady reading economics. What is the chance that this lady has economics degree, right? So even though this is very reading economics is very representative of economics degree holder, but you cannot say that conditional on the person is reading economist, the likelihood for him or her to be economist or economics degree holder is very high because the base rate, right? The base rate of economics degree holder in Singapore, in any country, is very small. So people tend to neglect the base rate, like base rate, or also like later on in this chapter, we also talk about this salesman, right? Salesman and the librarian. We say that even though typically salesmen are outgoing or extrovert, and librarians are introvert and quiet, but it's still right, relatively easier and more likely for you to meet an introvert and quiet salesman compared to a quiet introvert librarian because there are so many more salesmen around in Singapore compared to librarian. Okay. So, and also representative bias, we also have this blue car, right? Blue car, yellow car problem. So there can be many calculation problems related to that. Okay. So that's the thing. And then availability bias. Availability bias is like you tend to form your impression or perception of something based on more easily available information, right? So I'm not going to cover all of the content, but it's like most salient those are salient example, right? So for example, many people, if you ask them, right? So which one is more killing, right? More killing, coconut tree or sharks? People may think that sharks are more dangerous, but actually every year, right, there are more people killed by coconut, falling coconut compared to sharks. So this is a pretty good example of availability bias. You tend to make heuristic judgment based on available information. Yeah, instead of looking to the detailed data. Okay, finally, anchoring bias is like anchoring effect. People tend to be influenced by what they previously see, right? Like many examples, if they have seen a number, right, a high number, they tend to predict the high number for the next prediction problem, even though the two problems may be totally unrelated. Okay, so basically that's this one. And by the way, also for lectures three, I think representative bias, there's another big topic which is like right. So the probability, like the joint probability is always probability for joint events is always smaller than the joint of separate event or independent event. Just like right. So this question, this example about if I right, so if I talk about somebody who is playing jazz, right, who is playing jazz and be accountant, so um, if I tell you that this person is in general, so uh, he's also kind of a very introvert, very quiet person, and in this case, people tend to think that the person is more likely to be accountant and less likely to play jazz, and they may reach a wrong conclusion that the probability for the person to be a accountant playing jazz is even like bigger than the probability that the person plays jazz, right? But we should clearly know that the probability of A and B, right, happens jointly is smaller than the probability of A or the probability of B. This is a simple mathematical truth. Okay, and then lecture four, we talked about mental accounting. Mental accounting, we started with the example of acquisition utility and transaction utility. So you remember, right? So there are kind of you want to buy a bed sheet. There can be double, queen, and king, right? So somebody may want to buy a king size bed sheet for his or her double bed, double size bed, just because they are sold at a different price. So in general, they thought that when they are buying a product with a bigger discount, they make a profit out of this trade, and they may mistakenly or illusionarily think that they win, right? So this may lead to some interesting decision pattern. And yeah, mental accounting related to prospect theory or loss aversion. We also talk about um, if people, right? So if people have a loss aversion and suppose that people have a concave utility function for both gains and losses, then in general, it's better for you to merge losses and separate gains, because if you merge losses, the total pain is smaller than if you have separate losses. And if you separating gains, the total happiness will be bigger than if you merge the gains. So that's simply from the graph. We also have a similar exercise question. So if you want to know more, you can also refer to the exercise or refer to the slides, right? So then we have sunk cost fallacy. Sunk cost fallacy is that in traditional economics, what you have paid in the past shouldn't affect your choice in the future. But many times people's decision may be influenced by some cost in the past, so, which means that yeah, they will just right, if they have already paid for something, they tend to right continue completing this thing. And then we also talk about house money effect. House money effect basically means that, so that's how basically we say like joking, that's how casinos make money, right? Casinos make money. House money effect basically means that without any preconditions, people tend to be risk averse. But let's say if you have house money, right? If you have just win some money from lottery, if you have just win some money from lottery, then in general, uh, if you have win some money from lottery, you are more likely to gamble. You are more likely to gamble. So that's the thing. And second thing is you have recently just lost some money, and then compared to doing nothing or not to gamble, if gamble give you a chance, or lottery give you a chance to recover your loss, you are also more likely to be risk seeking, or you're also more likely to gamble, right? So um, basically, house money effect refers to both situation that you have won some money to cover the loss, or you have lose lots of money, but lottery give you the chance to recover the loss. Then under these two conditions, people are more likely to gamble. Okay. And then we have naive diversification, very simple thing, right? So people tend not to pay attention to what is in the options, but simply apply 1 over n rule over the n options they have. And sometimes it's irrational, right? So that's naive diversification. And finally, we have money illusion. Money illusion refers to the case that people think about things more in terms of nominal terms instead of real terms. Yeah, they not only apply to money, right? Not only apply to money. So basically, especially people tend to ignore the influence of inflation, right? So for example, like the example say, right? So people or people kind of understand that if you have 2% salary increase and no inflation, you get net salary increase of 2%. But if you have 3% salary increase but 2% inflation, you're gonna get 1% real salary increase. So the finding of the money illusion in literature is that people are in general able to calculate real salary increase or real price impact. But on the other hand, their happiness or unhappiness level depends on are influenced by money illusion, which means that okay, when they are evaluating which one is more profitable, they know that 2% salary increase with no inflation is better than 3% salary increase and 2% inflation. But at the same time, they still think that they will be happier in the second option with a 3% salary increase and 2% inflation. Okay, so that's money illusion, one example of money illusion. And there are also other examples of money illusion. So for example, different rounding rules. And you may also have some other things, or even like in non-monetary, right? Like in probability domain. So for example, like this lottery thing, right? So for example, uh, if you have points to bid for your, let's say, courses, right, in the course registration system. Actually, if I give you 10,000 points and 20,000 points, as long as if everyone get the same number of points, right, uh, the easiness and difficulty of getting each course will be the same. But people may just feel happier if they have 20,000 points because it looks bigger. Okay, and finally, lecture 5 about time preference. Time preference is also a very, very important topic in behavioral economics. So the key concept, right? The key concept of this chapter is that, okay, we have the so-called the present bias and time inconsistency, present bias and time inconsistency. So present bias is something we introduced, right? So it's also sometimes we call quasi-hyperbolic discounting. Namely, in traditional economics, right? So we know that people are impatient. They prefer salary or utility now compared to future. And of course, they also prefer early future than late future or near future than far future. Okay. But in traditional economics, we normally assume what we call exponential discounting or kind of a constant discounting. Namely, the discount rate between today and tomorrow is delta, tomorrow and the day after tomorrow, also delta. 2 days later, 3 days later, also delta, so on and so forth, right? But present bias basically refer to the situation that the discount rate may be different across the days. Okay, so here, let me see if the volume goes correct. Hello, hello. Okay, I hope it's still picking up voices. Okay, so so present bias refer to the situation that um people have a very big discount rate before now and tomorrow, and discount less or discount to a lesser degree for near future and far future. So more specifically, right, that refers to the situation that, let's say, people may have a discount between today and tomorrow is like 50%, like $1 tomorrow is only 50 cents today. But for, let's say, 100 days later and 101 days later, people may pretty much think they are the same. Or so to say, maybe they think that $1 in 101 day later is worth 90 or $99, 90 or 99 cents of 100 days later. Okay, so um, that's a very important pattern we want to study in this lecture. Um, More specifically, in terms of modeling, right? So basically, a quasi-hyperbolic discounting model just have this kind of so traditional exponential discounting is like if you think about t days later in the future, right? T periods in the future, in general, your discount factor should be delta to the power of t, namely how many days you just discount by t to the power of t, delta to the power of t. And quasi-hyperbolic discounting means that your total discounting factor will be beta times delta to the power of t, right? So beta is the measure of present bias, or sometimes we call it myopia. So which means that, so between today and tomorrow, you have extra discounting, like between now and future, which is beta. And beta is typically also less than 1. So that's the main idea of present bias. And yeah, so because of present bias, we also have this kind of overall time inconsistency pattern or bias of people's behavior. And more specifically, it's just like, in one sentence, it's like people appear to be more patient to trade off between near future and far future time compared to the same time interval from now and future. So people appear to be more patient when they are moving away from now. So just like many examples we see in this chapter, right? If you choose between today and tomorrow, you tend to appear to be very myopic, very impatient, choosing, let's say, the unhealthy choice or giving a very high discount rate. On the other hand, if you're trading between two time points in the future, right? Like in 1 week or in 2 weeks, then you appear to be more patient, and in general, you tend to make better choice. So timing consistency is in general like that. So, so if you let's say if you have the structure of this kind of problem is obviously like this, right? So suppose you have two options A and B, like between now and tomorrow, and the C and D is like between 100 days later and 101 days later. Time consistency basically means that if you choose A over B, C over D, it's consistent, or B over A and D over C, that's also consistent, which means that you have very consistent trade-off between later dates and earlier dates. Either you always choose later or you always choose earlier. Time inconsistency basically means that you tend to choose earlier, right? You tend to have more impatient choice between A and B, you choose A, and normally you choose D, but you choose D over C. Namely, in the future days, you choose the later option. Okay, and we may also have some calculation questions related to this topic. Okay, so in general, I think that's more or less the key knowledge points of the five topics, the first five topics. Okay, I hope this summary can help you to have a better overview of what we have covered, the topics we have covered. And so basically, if you have no difficulty at all, right, following this session, understanding every sentence, every word I say, so that probably suggests you have pretty good preparation for the course and for any related possible exam or test. And if you're not familiar, also don't no need to worry too much. Just well, wherever, right, wherever you're not sure what I'm talking about, just try to go back and read the slides very carefully. And yeah, that can always help you to make better preparation. Okay, I think that's basically all for this session. If you have more questions, also feel free to ask me via email. Okay. Um, yeah, so basically, I think that's all for the review session. Thank you very much. And I wish you all the best. Okay. Thank you.